All right, welcome back. We're going to do some more multiplying and dividing rational expressions. So today I've got some more advanced ones for you. If we look at this, we've got a whole lot of stuff to deal with before we are ready to look for factors to cancel. Let's deal with these things one at a time. And when I've got a lot to deal with like this, I kind of like to label the parts that I'm working on. Something like A, B, C, D, or maybe I'll use Roman numerals 1, 2, 3, and 4. Just so that I can deal with one part at a time without getting confused, and so that when I go back to putting everything together, I can easily tell where everything goes. So I'm going to deal with A first, and this is the numerator of the first fraction here. So this is x squared minus 5x plus 4. And my goal is to factor this, which means I'm going to write it as some pieces multiplied together. Or another way to think about it is that I'm writing it in a way where all those pluses and minuses are sort of contained in little parentheses packages. Because I have an x squared here that does not have any coefficient with it, there's no 2 in front of it or anything like that, that tells me that I can just use the basic factoring method where I'm going to write x in both parentheses. And now I'm going to try to think of two numbers where when I multiply those numbers, I get positive 4, and when I add those numbers, I get negative 5. Those numbers turn out to be negative 4 and negative 1. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. So this is all set for A. Now I'm going to look at B. B is 2x squared plus 4x. When I've got two terms like this, maybe your first thought is to try difference of squares. But difference of squares isn't going to work here for a couple of reasons. There's no number times itself that would give me 2. I've got an x here that's not an x squared. But because both terms have an x in them, that tells me that definitely the first thing I want to try is looking for a greatest common factor. So in class, we've talked about splitting things up to make it easier to find those matches. I'm going to write 2x squared is 2 times x times x. And because I want to try to find some matches, instead of 4, I'm going to write 2 times 2. Oops, that should be a 2 times x. Now, this 2 and this 2 are a match. And this x and this x are a match. So in front, I'm going to write 2x. And then inside, I've got an x that didn't match plus 2. At this point, it's a good idea to look and see if there's anything else we know how to do here. But I don't see anything. X plus 2 is pretty much already done. There's no way to break that one down any further. So I'm going to stop here. Now let's look at C. C might look, to start with, like it's already done because we just have x and a number, but they're in the wrong order. And we know that when we have the wrong order of subtraction here, we want to switch that order, turn that 1 minus x into x minus 1. And when we do that, we need to write a negative 1 on the outside, or you could just write a negative sign. All right, we're almost there. Now let's look at D. D says x squared minus 4. And finally, I do get to use this difference of squares rule. I want one thing where when I multiply it times itself, I get x squared. That thing is x. And I want a second thing where when I multiply it times itself, I get 4, and that is 2. And then the rule is a plus and a minus. Doesn't matter which order you write. So to summarize, we used the basic method for A. We used the greatest common factor, or GCF, for B. We used the switch subtraction rule for C. And for D, we used difference of squares. All of these methods can also be combined together, but in this problem we didn't need to. They each only needed to use one. So now I'm going to rewrite this whole piece. If it helps you, I'll write A over B divided by C over D. That's where we're going to put all of these factoring answers that we got. So A comes first. That's x minus 4, x minus 1. Next is B. I've got 2x times the factor x plus 2. Now I'm going to divide. C is negative 1, x minus 1. And D is x plus 2, x minus 2. Okay. Now, the rule for dividing is keep, change, flip. So I'm going to keep this fraction. I'm going to change this division into multiplication, and then I'm going to flip this last fraction. There we go. Now I've got, so now after all that, I'm finally ready to look for matches on the top and bottom that I can cancel. And I see this x plus 2, x plus 2. And I also see x minus 1 with x minus 1. Looking carefully, I don't see anything else that matches. So now I'm just going to write all those leftover pieces in one fraction together. I'm going to multiply across the top, x minus 4 and x minus 2. And I'll multiply across the bottom. 2x times negative 1 is just negative 2x. Okay. This is looking pretty good. You could stop here, depending on what the problem is asking for. But let's take it a little bit further. So first of all, you can write a negative sign on the bottom like this. It turns out that that's the same as writing that negative sign on the top. Dividing by negative 1 is like putting it on the bottom. Multiplying by negative 1 is putting it on the top. And those two things do the same thing. Either time that you multiply by negative 1 or divide by negative 1, you're basically keeping the same thing but changing the sign. So I'm going to write this as a negative x minus 4 x minus 2 over 2x. I can distribute out these two factors. So I'm going to keep that negative in front for now. X squared minus 2x minus 4x plus 8 over 2x. that's going to be negative sign x squared minus 6x plus 8 over 2x. And now I'm just going to take this negative sign here and distribute it. So this is going to give me a final answer of negative x squared plus 6x minus 8. When you have a negative sign, all over 2x. When you have a negative sign in front of parentheses like this, it changes the sign of each term that comes after. So my negative x squared became negative x squared. A minus and a minus here makes a plus 6x, and then it's a minus 8. Okay. So that was an example of dividing two rational expressions where each one of the numerators and denominators requires a little bit of factoring work before we get started. Let's see another one of these with multiplying. All right. So I've got 2x squared plus 2x minus 84 over 15 minus 5x times x squared minus 9 over x squared plus 9x plus 14. I'm going to go through the same process. I'll go a little bit faster this time since it's mostly going to be the same. I'm going to label these A, B, C, and D. This isn't required, but I think it really helps to just keep your work straight and organized and make sure you understand why you're doing each part that you're doing. So for A, I've got 2x squared plus 2x minus 84. I notice that all these are even numbers. That means I can divide each of these numbers by 2. So I'm going to take out a greatest common factor. 2 times x squared plus 2 times x minus, I'm going to write 84 as 2 times 42. Now that lets me write a 2 in front. X squared plus x minus 42. I got this by matching these three 2's. That match goes in the front. And then whatever I didn't match, I write on the inside, keeping those same pluses and minuses as well. Okay. Last time we did this greatest common factor and we were done. But looking at this, I still have 3 terms. I still have an x squared. That's a signal that I need to keep trying. So I'm going to look for 2 numbers that multiply to equal negative 42 and add up to positive 1. Because if I wanted to, I could put a 1 before this middle x here. Six times 7 is 42. So it's going to be, those are 1 apart. It is going to be a 6 and a 7. And because I want a positive 1, it's going to be a positive 7 and a minus 6. Now looking at this, I really am done. There's no other steps I can do with this polynomial that I started with for A. Let's check out B. (15 minus 5x). Both of these are multiples of 5. So I can do 5 times 3 minus 5 times x. Match the 5's, put those on the outside. And then what's left is 3 minus x. Now I've got to switch. So I'm going to write negative 5 x minus 3. Okay. These were the tough ones. C and D are not going to be so bad. For A, we had to do GCF and then basic method. For B, we had to do GCF and then the switch rule. For C, easy peasy. It's just going to be the normal difference of squares. I've got x squared minus 9. We're used to this one by now. It's x plus 3. x minus 3. And then for D, this is going to be the basic method again. X squared plus 9x plus 14. I want two numbers that multiply to equal 14 and add up to 9. That's 2 and 7. So now once again, I'm going to take all these A, B, C, D pieces and I'm going to put them where they go based on the original problem. The original problem was A over B times C over D. So I'm going to write 2 x minus 6 x plus 7 over negative 5 x minus 3 times x plus 3 x minus 3 over x plus 2 x plus 7. Great. Now I'm going to look for matches. X minus 3 can cancel. X plus 7 can cancel. Looking through this, there's nothing else that jumps out at me that can cancel. So I'll have 2 x minus 6 x plus 3 over negative 5 x plus 2. We can stop here, or we could keep going. Let's distribute this out. So again, when I have a negative sign on the bottom, it's more standard to just have the negative sign be on the top and have the bottom of the fraction always sort of have a positive sign in the leading term. So I'm going to write this as negative 2 x, I'll distribute this out. So x times x makes x squared plus 3x minus 6x minus 18 divided by, remember I moved this negative sign to the top, so this is just going to be 5 times x is 5x. 5 times 2 is 10. Oops, there we go. Now I will combine like terms here and distribute this. So I have negative 2 x squared minus 3x minus 18 over 5x plus 10. That's going to make negative 2x squared plus 6x plus 36, I'm doing this, over 5x plus 10. And here is my final answer. So, once again, we factored each of these 4 pieces using the different methods we've learned about. This one was difference of squares. This one was just the basic method again. And then we put each of these pieces in the place that it came from, found the matching factors, canceled those. The rest of them we multiplied out. All right, thanks for watching. I'll talk to you again soon.